as we have seen now that electromagnetism are inducing any current. So we have seen that with the help of force and magnetic field, we can produce current also. Okay, so three of these things are necessary to produce any of the third thing. Like any two thing here we can use to produce the third thing. So here when we are using these two things, so we can produce the third thing like this, and when we are producing it, so we are calling it as the induced current. Okay, so here let us see what is induced current first. This is a current which is produced by electromagnetic induction, and it is known as induced current. And electromagnetic induction, we have already seen that part. Okay, so direction of induced current is found with the help of Fleming's right hand rule. Yeah, earlier we have seen Fleming's left hand rule. I guess you know what is it. It is used to find the force when we have magnetic field and current. When these two things are given to us, then we can find this third thing, and that is done with this left hand. Okay, now if we are taking the right hand, then again the same thing is happening. FBI that I have told you, F for force, B for magnetic field, and I for current. The same thing is going to happen again. But when we are producing current, then we have to take right hand. So this is about the induced current. Now it is measured with the device that is known as galvanometer. Okay, actually galvanometer earlier was taken as just a sign of the current. It is just an indicator that yes, current is produced here, because galvanometer is like this. Okay, and in earlier time, what is happening with this thing, whenever there is a current, and if we want to check that, like in today's scenario, I hope you have seen the tester, electricity tester, right? And you have seen that how we can test this thing. There is a tester and we just put it in the socket, and if it is showing a red color light, then we can judge that yeah, it is current is present here. In the same manner, this was the device that is known as galvanometer, and if it is deflecting like this, so the deflection of the galvanometer is suggesting that yes, current is present here. So this is galvanometer. It deflects either left or right depending upon the flow of current. Like once if we are taking the terminal of the batteries here like this, positive and negative, so positive to negative like this it is going, and it is deflecting in this way. Let's suppose, so if we are interchanging the position of the battery like this, and it is positive and negative, so it will show it in reverse direction and it will deflect like this. So I guess this is understood to you that galvanometer is used to detect whether the current is present or not. Okay, so here because we have induced the current here, so inducing current, now we want to check whether our stored thing is a current or not. So how we are going to check that? We are going to check that with the help of this galvanometer. Fine. So see the experiment 1, and as I have told you that we just need these two things to produce the current. So how we are gonna make it? Okay, see here in this diagram, what we have done here. Here is a coil that you can take a soft iron core. Let's suppose this is a soft iron core. Okay, and here the wiring is coiled on it like this, and we have just connected two terminals with the galvanometer here. Okay, now this is a bar magnet, that is a permanent magnet, and now we are forcing it like making it in motion, and we are perpendicularly making the motion here, like हम इसको एक बार input डाल रहे हैं फिर बाहर लेकर आ रहे हैं. So we are providing a motion in it, and that experiment is easy to do. You can do that experiment at home also and in the physics labs. Okay, like the various laboratories are here. So at this point, what you will see, when you are moving this magnet inside and outside like this, so you are producing here motion comes with the help of force, and this is going to change the magnet, because this is a magnet, so magnetic fields are going to change in contact with this coil, and that is going to produce the third thing, that is current. Now you will see that there will be the deflection in the galvanometer. So this is what the experiment 1 is showing. So one thing here to see the major part is magnetic field is not constant. It is varying. Okay, I must say it is varying or changing simultaneously, like the magnetic flux. Flux means, I have already told you, magnetic flux means magnetic field. So magnetic flux is changing here accordingly, like we are putting it inside and making it outside. So here the magnetic field, like this is the north and the south pole. Okay, so from here to here, like this, magnetic field must be going like this, it must be going like this. Okay, so when we are pushing it near to the coil, so more of the magnetic field are in contact with this coil right now, and we are moving it out like this. Now less of the magnetic field are in contact with it. So, but we are definitely be sure that there is not a constant magnetic field right now, and that the single thing is the reason for producing a current that is known as induced current. Now let us do experiment 2. So what is happening here? Here we are having different conditions, as you can see in the diagram. In first diagram, as you can see, here is a metal wire, a galvanometer that is detecting the current wherever it is present or not, and the motion of the wire. Okay, so in second one, as you can see that hands are doing motion with the wire, and that is too in the perpendicular direction. Okay, so wire is moving here in the perpendicular direction, and as you can see, here are the magnets. So one is north pole and one is south pole. So magnetic field lines must be going like this, north to south pole. And if a wire is cutting it in this perpendicular direction, so we can say that this wire is cutting the flux in the perpendicular direction. And when you know that in 90 degree, in shape of 90 degree, if it is making with the magnetic field lines, then it is observing a maximum current is flowing through the wire. And that is now you can see in the galvanometer. Galvanometer is deflecting from its original position. And when we are doing it in opposite direction, earlier we were doing in upward direction, we were bringing it upward, so it is deflecting here, and now we are again putting it in downward direction, so it is deflecting in this direction. So all this experiment is literally showing us what? That here with the help of force and with the help of magnetic field, what we are doing? We are inducing current. Okay, so that current could be stored and later on can be used, as in, you know that in the inverters, when the light goes off, like electricity is not here, so what we are using? We are using inverters. So inverters are what? They are stored charge particle, that is in the form of chemicals, and we are again using and transforming it, and this is going to convert from the chemical energy to the electrical energy, and now we can use that energy and we can study well. So students, let us see how now we can easily convert this thing and store it in the devices.